Okay, Bismillah ar-Rahman ar-Rahim, wassalatu wassalamu ala nabiyyina Muhammad wa ala alihi wa sahbihi ajma'in. So today it's a very important lecture that is going to give you the big picture about building a full stack IoT application. So far we have introduced so many concepts. We introduced sensors, we introduced actuators, we introduced middleware. So the different parts of an IoT, ecosystem. And now the objective of this course is to build an IoT application which goes from the sensor device, sending data, getting the data sent through the internet, for example, a middleware. And finally, which is the most important for us as a user, is to collect this data and visualize it through a dashboard. A dashboard that will provide you, for example, the different numbers that will be collected from the Internet of Things. So during this lecture is going to be a small lecture, then I go to the programming part to show you how we can develop a simple yet comprehensive an IoT application, full stack, from the sensor node until the dashboard. So today we're going to introduce the full stack IoT architecture from the sensor to the dashboard. And you will learn how to design an end-to-end solution that collects environment data. I'm going to apply this to smart agriculture monitoring and process it efficiently, send it through the middleware, and finally present it to the farmers to give them insights. Okay, so at the end of the lecture, you will learn how to design an IoT architecture, how to implement sensor networks. So in this particular example, I'm going to use a Python script to emulate sending the data from an IoT device or for multiple IoT devices. We're going to work also on RabbitMQ. In the last lectures, we introduced RabbitMQ with a different type of exchanges. But today, we're going to see how we can use these exchanges efficiently, depending on how we would like to send the data and how we want to collect it within a real-world context. So we can also develop data processing at the back end and to visualize also the interface, where we're going to collect the temperature here, the humidity, and the moisture level that will be sent by the sensors. So this is the objective of today's lecture. So what is a full stack IoT system? As you can see here, this is an abstraction view about a full stack IoT system that goes from the physical layer, which is the sensor node itself, which are the sensors and actuators. So sensors collect data like temperature or humidity. And then the next layer is the network layer. And here we talk about how we can transmit and transfer the data between the sensors and to the end user. We talked about this several times in the previous lectures. And in the last week, we introduced RabbitMQ as one of the scalable solutions to send data through the internet, using the MQTT protocol or the AMQP protocol, or even like we're going to do today, we're going to use the REST protocol using Flask. And you can also use WebSockets. So the third layer is the application layer, and this is where you will define your business logic, which in this case, I'm going to do something very simple, a simple HTML interface with JavaScript to collect the data from the RabbitMQ. This is what we are going to do, something very simple. And the objective is to visualize the data. So we can process the data, we can make front-end visualization as already introduced, and also we can interact with an API gateway. Another important thing also is the data layer, which is about storage. When you receive a lot of data from the internet, you would like to store it into, for example, an SQL database. And further, you can do time series analysis, so you can analyze the data as it goes over the time. And the requirement of full stack IoT systems, usually we need to have low latency. For example, if an event is triggered by the sensor, I would like to know about this event within very small amount of time, 1 second, or even less or more, depending on the requirement of the application. Scalability, we talked about this several times, because we're going to handle millions of devices, usually in the real context of an IoT system. And fault tolerance, we must make sure to deliver messages even in case of failures. So this is our simple application. We're going to have a Python script that is going to generate some random values to emulate a farm ecosystem. So we're going to generate temperature values, humidity values, and soil moistures. And in our case, we're going to use RabbitMQ using the Pika library that we have introduced last time in Python. And we will send messages using the fan out exchange, the direct exchange, the topic exchange, and the header exchange. And we will discuss what is the benefit of each of these exchanges to deliver the message in a proper way. Okay, for example, now the fan out exchange, it can send to everyone, but this is not always efficient because sometimes I need to filter for some particular subscribers or some particular end user applications. So through the RabbitMQ, we're going to distribute the information to a dashboard, to an alert system, and to a data analyzer, wherever we want to send the data to. Okay, so this is our use case. We will have a scenario where we send temperature values, humidity, and soil moistures. We're going to define alert messages for critical conditions, which we will choose that if the temperature is going to be more than 30 and the soil moisture below than 20, so I'm going to send an alert to the agriculture, okay, to make sure to make proper action in real time. So the farmer access the real-time data via a web dashboard. So we're going to emulate a farming system that uses IoT to get the information from the farm in real time. And the technical goal here is to collect high-frequency sensor data. We're going to send one message every second, and this means we'll send at a frequency with 1 Hertz sampling. Of course, we can change this, but in our case, we're going to send at high frequency with 1 Hertz sampling, and we will route the data efficiently to processing and visualization using the RabbitMQ. And now we're going to address the challenge of heterogeneous type of data. We have different type of data here. We have network constraints that could be also challenging. For example, the connectivity can be broken at some point in time. But one of the advantage of RabbitMQ is that it has a queuing system that will help storing the information temporarily and then resuming the sending when the subscriber will be on an active state. Okay, so this is the high-level architecture that we will have. So we're going to have sensors, RabbitMQ. Okay, we will send the sensor data through RabbitMQ. We will have a Python backend that will process the incoming data, and then the Python backend will send to a Flask. We can use a Flask or Fast API. Do you know what is Flask or Fast API? Have you used this before? So these are Python libraries that allows you to make an invocation of a service. So if you remember in the previous lecture, we have introduced the concept of service-oriented architecture. You remember this when we introduced the four categories of middleware. So service-oriented architecture, it means that a node can send a request to a server to get back a response. And there are different libraries on Python, and the most popular one are Flask and Fast API. Fast API is probably more elaborated, but this is a very simple example. So I'm going to use Flask to introduce you to how to make a simple REST API. And so we will have the message broker, the back end, the front end, the storage as we already introduced. Okay, so these are just slides to guide you going through the examples. I prefer now to go directly to the coding part. Now, just to get you motivated, let me run the application first. Okay, so here I'm going to start the sensor emitter. So here I have the following file, which will emulate IoT devices. Is the screen clear? So what we will do here, we're going to connect to RabbitMQ. It's the same RabbitMQ cloud that I have used last time. So I get the connection here, and then we will define different exchange. Okay, before going into the code, let me just start sending sensor data from here. Okay, it's not connected because I need to change to the network. Just a moment. Look, now we have the sensor emitter is going to connect to RabbitMQ and start sending. Okay, and my objective, now imagine that you are a farmer. The objective is actually to be able to visualize the data here. Okay, so here I have a dashboard that contains the temperature, the humidity, and the moisture. And for this, we're gonna run another node, okay, which is a consumer. This consumer is related to the web server, so this is a web data server. Is going to consume the data that comes through RabbitMQ and then send this data back into the front end. Now, if I go to the front end again, look, I'm getting the data. Okay, so I'm going to show you the magic behind sending the data from IoT sensor and collecting it through the dashboard. So at the end, you will be able to build full stack IoT application starting from the sensor data going into the dashboard visualization. Imagine that you have a farm, and now using this dashboard you can observe whether you have a critical alert into your farm. Okay, so now for example all the values are correct, and we will be able to define some critical values. For example, if the temperature goes, look, low moisture is below a certain value, is going to trigger an alert. Okay, so this is how the full stack application works, and now we're going to go into the details to teach you how you can develop something similar. So it's pretty much amazing and exciting to be able to connect your data. Now this is connected through the internet. It's not running locally on my computer. It's going to this server, AMQP Cloud. AMQP Cloud. Okay, so now if I stop the server, this server that I'm running here, it's taking information from the publishers, from the sensor node, and also helping the consumer to get this published data and visualize it through the dashboard over here. Okay, so this is just to show you again. This is the RabbitMQ server that I'm running right now. Now, if I stop this service, I'm going to stop the whole application. Okay, so you can easily create a simple RabbitMQ instance of Cloud AMQP, and through which you will get the credentials to connect. I'm going to show you this, and you will be able to build a full stack IoT application as the following. Okay, now let's get started from the programming part. So please pay attention, because this is something very useful later on, even for the midterm. The programming part of RabbitMQ is something important. So please try to follow and try to understand every single piece of code. It's not difficult. It's very simple. I'm going to explain it again. So the first of all, I'm going to define sensor device. So think about this as an Arduino node that is connected to temperature values or humidity values or also air quality. Now what we will do, first of all, I'm going to create a connection to RabbitMQ, and to make things simple, I defined here a utility script that contains wrap up the connection to RabbitMQ. Okay, so RabbitMQ, which is now located in my server, it requires the following parameters: the host, which is the server itself, the port number, the name of the user, the password, and the vhost. So all this information, you get them from AMQP Cloud, and when you get this information, you can store them into temporary or into environment variable file, which we usually call it .env. So this is a good practice. Usually these are critical credentials. We should not disclose them. Of course, I'm using this just for teaching purposes. I will change this after the lecture, but usually when you have critical information like a password, like the host name and so on, you don't want others to access without your authorization. So what we will do, instead of hard coding this manually, now for example, usually if you don't do the good practice, you will come here and you will put the password equal, and you will do it in this way. it will work, but this is not a good practice in software engineering. So the good practice is that we hide them. This .amp file is a hidden file. It will not be shown because it starts with a dot. So we can store them here, and then in the connection we will use the OS library in Python to get the name of the environment variable. Look now, if you want to get the name of the host, you do os.getAnv, and this will bring the environment variable of the host. So this is exactly like making equal to the host name, but now it is hidden in the .amp. And in this way I can bring the host name, and now imagine that you show this code to others, you will not disclose your credentials. So this is a very important good practice to make it, is you create a .amp file where you hide all your credentials, and then in Python, very simple, you import the operating system library and you use .getAnv, and this is going to bring the environment variable. Now look, if I do echo and I think I need to start this one to make it work, but let me check it. Okay, RabbitMQ. Now it is not defined because I need to run this first into this terminal. But for example, I can show you other credentials. I have some like path, or let me check if I have an environment. Look, I have an environment variable path that I can find with echo here, and I can find with os.getAmp. Anyway, so this is the first step, is to make a connection. And the connection here, this is the classical way to do it with Pika, is to put the credentials. Look, now the credential is the username and the password. And finally, to put these credentials here inside the connection parameter of Pika. And if everything is fine, you will have a connection that allows you to send messages or to subscribe to messages. Okay, is it clear? Okay, so first of all, we get our credentials. We create a credential object using pika.plain credentials. So you will wrap up the password into a structure, and then you define the connection parameters. Okay, Pika connection parameters, it will take the host, the port, the vhost, and also the credentials. And at the end, you do Pika.blocking connection. There are different types of connection, blocking and non-blocking. Here, we're going to make a blocking connection. And we will use this connection to later on publish messages through the sensors, or create consumers that will subscribe and get the information that is sent by the publisher. Does this make sense? Okay. So moving forward and going back to our sensor. Okay. So now I will import getRabbitMQ connection, and I will create a connection here using the credentials that we have defined. And in order to be able to communicate, when you create a connection, you need to define a channel. Okay, the channel through which you will make a connection. So connection.channel is going to create a communication channel between the publisher and the RabbitMQ, the middleware. And here you will define your exchange. When you want to communicate, as we already introduced in the previous lecture, there are different types of exchanges. A direct exchange, a fan-out exchange, a header exchange, and the topic exchange. So because we are doing an illustrative example, we're going to define these 4 exchanges, and we will use them to send the data. So for example, let's see how we will use these exchanges efficiently in our application now. So here I'm going to make a while loop that will send forever, that will keep sending the data forever. And we will have to generate a random value for the temperature, a random value for the humidity, and a random value for the soil moisture. This will emulate an Arduino device that is sensing the data and sending it through the internet. And something very important here is that when we want to send the data in IoT application, we need to send it into a structured format. Please pay attention. These are important information you will certainly have exams and questions with. what I'm explaining now, I'm recording it because it's very important. This is the most essential part in the course. It's how to build a full stack IoT application. I'm saying very important things. Now, although you can send any message as a string, it's not recommended because usually the consumer need to understand what is this string about. So the proper way to send the messages is to send them in structured format. And the best way to do that through IoT or usually internet application is to make it as a JSON format. You know what is JSON? So a JSON structure is a dictionary in Python, which is characterized by key and values. So now when I send this payload to the consumer, I will tell there is a field that is called timestamp, okay, which is the time of the measurement. Because when you send the measurement, you want to make it a timestamp when I have taken this measurement, because every time is important regarding to the measurement. And then I'm going to send the data itself. The data that I have generated here, this is the temperature. So this is the key. It will read the key, and now it knows that this value corresponds to the temperature. And now this is the key that represents the humidity. And the consumer is already aware that I'm going to send agricultural data, and it knows that I'm going to send a temperature. It knows that I'm going to send a humidity, and it knows that I'm going to send a soil moisture. So I put this in a structured manner so that the consumer will find it very easy to collect these values later on, as we're going to see in the different consumers. And this is the device ID. So here I made only one device. I can make also the device as changing a random number. It's like emulating sending from multiple devices at the same time. But to make things simple. So this is a dictionary. Now, if I want to send any dictionary through the internet, I need to send it as a string. You cannot send any kind of structure through the internet, only as a string. So the way to do it in Python is to use a JSON.dump. Is going to convert this dictionary from dic type into a string type. So it will keep the structure, but will change its type to a string. Because if you don't send a string, okay, a string is a set of bytes, because usually we're going to send bytes through the internet. We're going to convert this into bytes, okay, through this string. And at the end, look at this payload, which is the message. I'm going to send it into channel.basicPublish. Channel.basicPublish, okay, this instruction is going to publish this message, okay, that you have collected over here. And we're going to create an alert. So this alert is going to be true if the temperature is greater than 35, the humidity is smaller than 30, and the soil moisture is smaller than 250. Now we get our data, we put it into a JSON structure, we converted this JSON into a string, and finally I am ready to publish. Now I have 4 exchanges. Look now, if I have an alert, if alert is true, I'm going to send what? I'm going to publish the message with a routing key alert, and here I will use a direct exchange. Look, sensor direct is the exchange that we defined as a direct exchange. So why do we need to send it here as a direct exchange? It's possible also to send it as a fan out, but a direct exchange is a good choice. Why? لأنه مش يرسلوا فقط للسبسكرايبرز that will consume only the topic alert. Okay, they will focus on this topic. Look, it will not send to normal devices. It will send to devices or consumers that are only interested into alerts. Okay, because the matching of the key here will be an exact matching. So only consumers with an exact matching of routing key alerts will be able to receive this message. Okay, now the second exchange I can send to a topic. Okay, so look here, I use a topic exchange, and here I put sensor.temperature. Now here I make the following structure. This will allow other consumers either to subscribe to all sensor topics or all temperature topics or both together. Now I can send the temperature as a topic, I can send the humidity as a topic, I can send the soil moisture also as a topic. And later on, using some filtering techniques, using wildcards, either the hashtag or stars, it's possible to let consumers choose which of these topics to subscribe to. The last topic is a header topic, okay? And the header topic will define a header that is defined as a JSON structure, as a dictionary. Now here I'm going to define a header. So the device type is environment and the location is field 1. So this will help to make filtering based on specific attributes. And this is very important. For example, if you want to have consumer that look only to the field number 1, or other consumers that would like only to look for a device type of type environment. If you have other type of devices, so you can make filter based on a device type or other attributes that you want to define on your own. Okay, so here we defined different type of publishers. So every time that you call basic publish, this message is going to be effectively sent to the RabbitMQ, waiting for other consumers to consume these messages depending on the way of the exchange, of the type of the exchange that we have defined. Okay, and here we're gonna wait a random time between 2 seconds and 5 seconds before publishing new messages. So this summarize in very easy way. This is a very basic example of publishers that allows you to send information to RabbitMQ. Now we're gonna look at the consumer that will consume these messages. Is this clear? Do you have questions? Okay. And now just going back to running this example. Okay, look now. Control C. Okay, just making Python sensors and sensor emitter. Look now. This is now it's first connecting. It's getting the connection, and now it is sending one message randomly every between 2 and 5 seconds. Okay. Now we get our sensor node sending the data to RabbitMQ. Now it's time to look at the consumers, at our application, okay? Because our objective is to make a full stack IoT system. So let's look at this server. Because now my objective is to be able to collect data here. Look now. Let me start the publisher. Look, this is the publisher. It's sending data. Okay, it's sending data, and now going to the front end, I'm not receiving any data here. So now my question, how can I make sure that this dashboard is able to receive the data? Now, first of all, we need to create a consumer. To be able to receive the data, we need to create consumers. Okay, they are subscribers to the data that will be published by the sender or by the sensors. So let's look at this consumer, which is a web data server. So this is the server that will collect the data from RabbitMQ and then send them through JavaScript to the HTML interface. Yeah, I think you already done a web development course, right? So you know what is JavaScript. We're going to use JavaScript in order to grab the data from a fast API, something very amazing. So here, how we're going to do it? So let's first look. Start the consumer. Okay, this is the RabbitMQ connection. We have Pika here, just a moment. Okay, yeah, we have Pika here. Okay, so we import Pika for RabbitMQ, and let me first go to the consumer part. Look, I'm going to start RabbitMQ consumers. So these are different consumers. Every consumer will be dedicated for something. One consumer, sorry, just to make it simple. We start RabbitMQ consumer. First of all, we need to make a connection. Okay, so you remember the connection. This is in util function. We have the connection that takes the credential and create a connection. And through the connection, I'm going to create a channel. So always in RabbitMQ, You create a connection, you create a channel, and then you define your exchange if you are going sending, and you make a queue declare if you are receiving. Okay, let me just take you again to see the difference between a publisher and a subscriber. Look now, here, when we did the publisher, we defined the connection, we defined the channel, which is basically the same as we did. Look, I'm going to compare. Okay, let's compare here. This is the connection, this is in the publisher, and this is in the subscriber. And here we have the channel, and here we have the channel. Now, when we want to send, we're going to define the channel exchange, because we're going to send, because the exchange is located in RabbitMQ. So RabbitMQ has an exchange and a queue. Okay, so the sender decide what is the type of exchange. Okay, look now, and even in the consumer, but here in the consumer we have another thing. We need to declare, okay, we declare the exchange, so it's sensor fan out, so it means fan out is going to receive everything, okay, to receive everything from RabbitMQ. And here we define a queue, okay, because you need to bind this subscriber to an exchange and the queue. Okay, so the queue here, it's a simple queue, and
Why do we need a queue?
لأن المسجز the consumer لا it will not come directly. هذا موجود في الكافكا. كافكا يعمل broadcast. RabbitMQ is going to store messages for some time. Why? Maybe the consumer is not alive. Look now. This is a sender. It's sending and there is no consumer. If I don't store the messages, all these messages are going to be lost. So what I can do, yes, so we can store them. When the consumer is out, it can consume the messages in the backlog. Okay, so now I declare a queue, okay, and I will bind the channel to that queue. Okay, look now, this is binding the exchange to the queue that we have created. So now you have an exchange and a queue, and this is typical for the subscriber. Okay, and there, for every subscriber, as already explained, for publisher subscribe, we must always define a callback function. The callback function, it will be executed when there is an event. What is an event? A message that came. Okay, so I'm going to consume that message. I'm going to execute a method which we call the callback function that will consume the message. Look now, we have our channel. It will receive from the sensor fan out, which we have defined here as well. And it will have a queue to store temporarily the messages. And we will bind the exchange, this exchange, to the queue. Now everything is in the RabbitMQ. RabbitMQ is going to understand this configuration and will dispatch you the correct messages when they arrive. Now, when a message has arrived, look at the callback here. The callback function, because this callback function, we're gonna declare it is the basic consume. مثل ما عندنا basic publish and the basic consume. It takes a queue, it takes a callback, and that's pretty much it. Okay, so because the queue now is, we have bounded the or binded the queue to the exchange. Now look now, when there is a message that arrives, I'm gonna take the data, okay, from the body, because the message will come inside the body. Okay, we have the header, we have the method مثلا post, get, put. We have different type of method, but here I'm going just to load the body as a JSON. So here we did JSON.dump. What does it do, JSON.dump? It converts the dictionary into a string. Now, when I receive the body, I receive it as a string, and I want to recover the dictionary. So I will use JSON.load. Look at this one. And look at, this is the opposite of this one. Okay? JSON.dumps is going to convert the message from dictionary. This is dictionary. Look, this type is dict. I cannot send a dict over the internet. I will send a string. So I need, it's a must that I convert it to a string. And now this is this method is a string. If I make print type of message, it will give me an str. Okay, and here if I print if I print type of data, it will give me a dictionary. Okay, now when you have a dictionary, you can use data dot temperature, data dot humidity, so you can access the values inside the dictionary. And this is what we want to do. So in order to make, we're gonna declare a global variable just to make things simple. It's a global variable that will take the latest data. Okay, the latest data here, okay, it's consumed, and I will tell you why for the moment. This is just to store the latest data that is received. And that's pretty much it. Now we have a consumer that will get the data and store it into a global variable. Okay, so we close the loop between the publisher and the subscriber. But there is another step, and this step is very important. Maybe it's something new for you. اللي هو service oriented architecture. And I want now, let me take you again to the dashboard. It's an HTML. Okay, nothing special. An HTML with JavaScript. This is page source. Look, very simple HTML. But here I have a JavaScript file, app.js. So let's see the magic now. This app.js, I'm going just to explain you. Is it clear?
يعني الجافا سكريبت هو اللي يربط
هو اللي بيربط لنا. ممتاز. يربط لنا ال HTML مع الاي او تي. اوكي. طبعا هو هذا اسهل شيء، لكن نفهم المعنى بعدين. You can use any technology. Okay. Let's understand now. This is the dashboard. We have JavaScript. What does it do, the JavaScript now? First of all, it defines a URL to a service. Okay, JavaScript will connect to a service using a function called fetch. fetch يعني أبحث على البيانات من السيرفيس هذا. Don't care about the syntax or the details. Let's understand the concept. JavaScript, it defines a function that allows you to call a server, and this server is going to return you a response. And again, the response and the response data should be in JSON. هذا راهو عبارة على standard, okay, on how to exchange data through the internet. We use JSON. You can use anything else. Like, to make your data easily accessible and exchangeable, we use JSON. So look now, this API URL, it defines a server in localhost. Of course, I'm going to run it here in local. You can run it also on the cloud. And this is the path to this service through a path API/sensor data. So I want to get this from a server at the path API.sensor data, and this is what we call a REST API. REST API, it's one of the paradigm in service-oriented architecture, which is very important. And look now, it's gonna fetch the data, get a response, and apply .json to get the response from the service. Okay, it's a complicated instruction. Don't worry about it, but just let's try to understand it. We fetch the response, we get the response, and then we extract the JSON. And finally, we have a function here which is called exchange. Okay, let me make console, no problem. That's a good point. Update dashboard. What does it do? It will extract data.temperature. So don't forget what we are sending now. What we are sending from the sensors. We're sending temperature, humidity, and soil. So this is going to come inside the object data. And then I will be able to collect it through data.temperature. So I'm going to put this into the HTML element that is called temperature element. إذا كان عملت شوية web development, you should be familiar with this terminology. Okay. Now, when you define an HTML page, it contains several elements. Now I'm going to update the value of each element with its corresponding with the data that comes. Okay, so going back to this HTML, look, I have an element. This part is an element for the temperature. This is another element in the humidity. This is another element in the soil moisture, which are defined already in the HTML code. Now, if I take this one, temperature element, I go here, which, okay, it has, what is the name? The ID is temperature. Yeah, it's defined by the ID. Okay, it's defined by, this is the ID. Okay, it's defined by this ID here. Save. So I'm going to access this data.temperature and update the element with the ID. I will do the same thing for the humidity, and I will do the same thing for the soil moisture. Don't worry about the code syntax. Just try to understand that we use JavaScript to communicate with a certain server. Now, we know that it communicates with server, but we don't know what is this server. And now, to know this server, what is about, it's defined here. This is what is defined using the Flask module in Python. Flask or Fast API allows you to define servers that you can invoke or you can request through clients. Okay, now going back in the top, here we have important Flask, and Flask has some other utilities as well, like the Flask course and so on. I'm not going to, in JavaScript, because it is a front end, we need to allow course. course هذه عبارة على security feature موجودة في البراوزر مش ما يسمحش أي شخص يعمل invocation على server لأنه لازم تصير authentication. If we want to bypass the authentication, نستعمل course. This is just an information. But what is important for us, look now, here we have defined the consumer and we have collected our data into the latest data object. Now I'm going to use to define a new service that is called get sensor data, which is defined in this path. What is this path? It is the same that I am calling in JavaScript. Look at this path and look at this path. So this Flask server is going to start a server at the port 4001, and this one is going to connect at localhost at the port 5001. So now we have the IP address, which is localhost, the port number, and the route to the resource. Okay? This is the route to the resource, which is the same as the following one. This is an example of service-oriented architecture. Why we call it service-oriented architecture? Does it make sense to you now, the word service?
Yeah.
Yes. So this one is offering a service. يقول لك أنا عندي في المنيو الآن أنا أقولها service-oriented architecture is like a restaurant. It has a menu. What is the menu of the service? What does it offer?
Yes.
It offers the latest data that we collected. صح ولا لا? And this one is going to collect, it knows that this restaurant can provide me a delicious dish that is called latest data. So it's going to consume it. Okay? So, of course, this is a service level agreement that if you ask me on this path, I'm going to provide you a JSON that contains the latest data that I collected. Okay? So this is the service that we are offering. Now, in this IoT application, we have used different types of middleware. We used RabbitMQ to transfer from the IoT device into this script. And now we're using a service-oriented architecture using REST API and implemented by Flask in order to allow other clients to consume it. And now this will allow the web application to be able to visualize these data. Look now at the magic. This is sending from very long time. Are we receiving anything? Nothing. Now let me start the web data server. What does it do, this data web server? Tell me الآن, what do you remember from this script? What is the first thing it will do? Now this is publishing from RabbitMQ. صح ولا لا? It's sending to RabbitMQ now. So this one, when it wakes up, what it will do? It will connect to RabbitMQ. First thing. Second thing does what? You have a publisher and subscriber, consumer. You quickly forget. I'm going to take you back to the code. This is what we do. We did the consumer, صح ولا لا? Now this is the code. Web data server. Web data server. So now we are consuming the message, loading the data, and saving it into latest data, and finally providing it to this endpoint. Now, starting this service, going back to my dashboard, just we wait the time for communication, and I get it. So how this happened? The IoT sensor node are sending the data to RabbitMQ. I have the file web data server. It's consuming the data from RabbitMQ and also acting as a server to the dashboard to send the data. هذا النود هو في نفس الوقت client وسيرفر. client لRabbitMQ it consumes the data عبارة لبروكسي وسيط. عملنا proxy consumes the data, send it to the dashboard. واضح ولا لا؟ Okay, so this shows you the full stack. طبعا there are many technologies. It's not only JavaScript, you know. There are many packages, technologies that you can use, Axios, PHP, well, you know, so many things. لكن the most important thing in this IoT course, you understand. حتى if you are not able to implement, don't worry. I don't ask you to implement this from scratch. طبعا if you are very excited, you can just taking the learning curve and try to build this code manually. And just to help you to do that, you know, I provide you the same content with incomplete instructions. Okay, so you can go and try to complete the missing parts in the Python code or the missing part in the JavaScript code. This will help you to increase your skills. وطبعا يحتاج بحث وبحث على الانترنت يعني even it's not obvious to build this manually from scratch. At least in the beginning. Like, if you are able to understand now how things go from a sensor node to the dashboard, that's awesome. Okay? Now, this is what I want you to understand. It's the whole loop. You know, we started from sending the data here from the sensors. Okay, look, we send this data to RabbitMQ. You know, we didn't send it to this dashboard. Now I can make other dashboards. I send it to RabbitMQ. MQ, you know, he will take care about how it wants to deliver that one. And now, independently of this, I create a consumer for this particular application, which is a dashboard. But this is not the only consumer. I'm going to show you other consumers right now. Okay, this is maybe the most difficult consumer because it consumes and it provides to a front-end application. Okay, so this allows us to make the full stack communication. But you know, as I told you, RabbitMQ is even bigger than this. It's not only for one application. It can serve thousands of applications, millions of applications seamlessly without even, you know, look now, this application is running, but I want another application that cares only about alert. تخيل عندي مثلا, I will make a simple device on the wall that has some red light, buzzer, and the screen to show me alert number. That's another consumer. So I can create another consumer just to tell me if there is an alert, it will highlight it. Okay, and for this, we can make another script which is called alert handler. Look, this script is not going to take into account of all the values. الآن استعملنا fan out احنا. استعملنا fan out in the previous one because I will care about all the values. This dashboard consumes all the values that are produced by the sensor. But now the second alert handler is going only to care about alert. So the same thing, I need to define a RabbitMQ connection in the same way, create a channel, create an exchange, and now What is the difference? Look at this consumer. It created an exchange to consume, but through which exchange? Let's look at the exchange. I want you to make a difference. Look, the exchange was fan out. What does it mean fan out? إرسال للجميع. Okay? هذا لا. Doesn't want to subscribe to everything. Doesn't look to noise. I look only to important messages because I want to take action only regarding alerts, not something else. So here it will subscribe to a direct exchange. And direct exchange only cares about the exact matching of the routing key. فهمتوا المعنى الآن؟ So even the name of the type of the exchange, it makes a lot of sense on how you want to utilize it. So now I'm going to subscribe to sensor.direct, okay, which allow me only to focus on a very particular type of routing key, nothing else. And the routing key is called alert here, which we have defined already in the publisher. If alert, look, if alert, I'm going to publish in the alert key. So I'm going only to listen to this publisher. I'm not going to listen to those publishers. Okay, so all of them are topics, and this one is direct. Either focused, خلاص, exact matching, nothing else. Okay, now the alert handler is going to subscribe to direct here. Same thing, we need to define the queue, you know, just copy paste this one, adapt it to your context. You make the binding, you bind the exchange to the queue and to a routing key. خلاص الآن focused. I'm going only to listen direct exchange on this alert routing key, nothing else. So very focused here, and that's pretty much it. You know, there is a callback as for any subscriber, and whenever there is anything is going to append the alert. You know, this is kind of a business logic. We don't care much about it. And finally, I will print it. You know, let's just focus about the printing. Let's make the alert now. Look, I have a publisher, I have a consumer, completely independently. I will have another device that will care only about alert handler. Keeping quiet, you know. Look, now there is an alert. There is a low humidity detected. And now look, this is going 35, it's another alert. Okay, now 16, this is normal message, nothing came. It only points out the alert and the type of alert. Okay, whether the alert is related to the temperature, to the humidity, or something else. And in this particular case, it was useful to use the direct exchange because it focused on one routing key with exact matching to the string. Does this make sense? Okay, and you can see now this application or this alert application is completely unaware about any other consumer. This consumer or this publisher is unaware about any other consumer or any other application. كل حد يشتغل في مجاله. شكون اللي يربط ما بيناتهم؟ Who is linking all of this? Is the RabbitMQ. This is why we call it's a seamless communication. بطريقة مخفية. Okay? هذا يرسل ولا على باله. وهذا يستقبل أي شيء موجود. وهذا يستقبل فقط الانذارات. اوكي بطريقه كومبليتلي سيملس. شفتوا قوه الرابط ام كيو الان؟ هو اللي يشتغل في الشغل هذا. All the magic is in the Rabbit MQ. And now programming wise, when you understand the exchange how they work, okay, again don't care about the instruction, you know, just copy paste it. The most important thing is you must be able to know the business logic. Okay, I can give you some exercise for this particular type of problem. What is the best exchange? You just put things together and then it works. Okay, another consumer is the data logger. Now imagine that you have a data logger that the responsibility of the data logger just, you know, logging everything into a database. So what kind of exchange here? What's the best exchange? If you want to make a data logger that logs everything, what exchange you're going to choose? That would be a question, by the way. I want to log everything. When we say everything, what is the best exchange? Topic? Direct? fan out, header. Which one? What is the exchange اللي قلت يرسل للجميع؟ بالي قلت أكمل مرة يرسل للجميع. Fan out. Okay, and this is why here we did a fan out exchange. لأنه data logger. I want to log everything, humidity, temperature, alert, not alert, everything. Because when you log everything to later on reconstruct what is happening. Okay? اللوج دائما نحرص أنه يكون فيه كل شيء. If you want only to log الالert خلاص نبدل هذا direct نعمل alert خلاص this is a logger alert logger. If I tell you change this data logger into an alert logger بسيطة جدا. I change the exchange type, I change the routing key to alerts, and I don't need to change the logging logic because it just takes the data and logging as it is. Okay, look now, I made the sensor fan out exchange, declare the queue, same thing, and then the callback, you get the data, you make JSON.load to convert it to a dictionary, and then I will take the timestamp, and then this is the logger. It's a CSV file that will log the timestamp, the date time string, the temperature value, the humidity value, the soil moisture value, and so on. What is our logging system? Let me check. We should have a CSV file here. Can you see any CSV file? Let me just open it. What is the path? I need to start it first. I need to start the data logger. It will first connect, and now received messages, and now every message that is received, it should be logged. Okay, look now. This is sensor data.csv. Look now. Any message received, it's logged. So now I can collect all the data and visualize it later on. Okay, I can go here to this one, running activities, going to the data here, IoT full stack data, and open this as a CSV file. Numbers. شفتوا الآن البيانات؟ يسوي كل لوج. نعم، إذا بعد أردت أنك تعمل إحصائيات تشوف عدد الاليرتس اللي صار you can do anything. You have your log. This is like a database. طبعا in sophisticated system we will do it into an SQL database for example. Okay, so later on you can make dashboards, تعمل Power BI, data analytics, and everything funny about this. Okay, so this is almost now the end of the lecture. In this lecture we have introduced the whole pipeline for a full stack IoT application. وفهمتوا الآن العلاقة من بين أول شيء درسناه لما تكلمنا. ترجعوا للشابتر نمبر 1. It's almost what we implemented today. Okay, going through from the sensor information, sending to the network, collecting the data through the middleware, consuming the data, and then you can either visualize it, save it, do any kind of data processing. Yes. No need. ممكن I will let you know. You must understand the code. لما نعطيك كود ممكن مثلا نعطيك كود ونقول لك غير الكود هذا. الآن مثل ما أعطيت لك المثال، ما عادش نحب نعمل داتا لوجينج، نحب نعمل alert لوجينج، وأنت تعرف أنه مثلا فيه exchange خاص بالالert، فتعمل التغييرات اللي تحتاجها. أوكي، without needing to memorize الأكواد موجودة يعني. If you filling in the blanks. I will not ask you في الإكزام writing a full code from scratch. مثل ما عملنا في الأردوينو. شفتوا في الأردوينو basic instructions you must know them and that's simple يعني. Okay, جميل. الآن we did everything. It's like there is no malicious people in the world, but this world is full of malicious people who would like to eavesdrop your data, manipulate it, change it, and this is all about security. Inshallah, in the next lectures we'll introduce security aspects, and I will show you some practical examples on how we can take the data, maybe change it in the middle, send it back without the other people knows. Okay, الآن we're receiving here the correct data into the dashboard, and I will modify this example to also change alert data to non-alert data. So the user will not be aware about this, and this will represent a security attack, and we will discuss together how we can mitigate the risks of security issues by implementing encryption or authentication or these different type of things. This is why you need to authenticate yourself when you log into any system. Okay, thank you very much and see you on Wednesday.